So as you can see, today's hot topic is work energy theorem. Work energy theorem, right? So what is work energy theorem? We all know that work done of all forces equals to delta K, right? So what do you mean by work done of all forces, right? So the all forces here are conservative force and non-conservative force. Okay, so you have to study separately which one will call conservative force and which one will call non-conservative force, right? So let's not discuss it here. So I can divide it like, divide means, yes, divide it like work done of conservative force plus work done of non-conservative force equals to delta K. Okay, so let's say work done of non-conservative force is 0. Okay, let's say let work done of non-conservative force equals to 0. Then work done of conservative force equals to delta K, right? And another case we have to remember that work done of conservative force equals to minus of delta U. What is delta U? Delta U is change in internal energy. Okay, so we can write it here like minus delta U is equal to delta Ke, right? So delta Ke plus delta U equals to 0. So delta Ke equals to Ke final, the Ke final minus Ke initial, right? Plus U final minus U initial, internal energy final minus internal energy initial equals to 0. If we derive this, then Ke final plus U final equals to Ke initial plus U initial, right? So ultimately we can write this like Ke plus U final equals to Ke plus U initial, and that and this is the formula of conservation of mechanical energy. Okay, conservation of mechanical energy. Conservation of mechanical energy. We have to remember that this is the main formula which is always valid, which is always valid, right? So when this formula will be valid? Now when work done of non-conservative force equals to 0, then this formula will be valid. This is the work energy theorem you have to understand, and also remember this formula: work done of conservative force equals to minus of change in internal energy. Okay.